everybody who is watching this fantastic video. I'm very happy to have you today, whether you're a national viewer or international viewer. My name is Sir OLENJOLAI Moko TAYAI Losingo. Simply just call me Sir and Engineer OLENJOLAI Moko TAYAI Losingo from beautiful country. So just simply call me Teacher OLENJOLAI or Engineer OLENJOLAI, or a mathematics teacher OLENJOLAI. So wherever that, just any initializations that you might use, you can just call me OLENJOLAI, that's all. I'm from Tanzania. I'm living my country, and this is our national flag. We like to welcome all the foreigners and also like to insist the Tanzanians to love our own country. So I have a good news for you. You have to stay tuned and join me when we are going into this fantastic business. Firstly, I would like to take this opportunity to welcome you into one of our online institutions. It's called Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM. Simultaneously, because I'm teaching engineering, higher engineering mathematics, I would like to welcome you into our YouTube channels at called Online Undergrad Institute of Tanzania, in square bracket OLENJOLAIM. So, the next question in your mind, possibly this is your first time to meet us. We would like to welcome you and have a comfortable moment when you join and learn in Online Undergraduate Polytechnic Institute of Tanzania. And the name of the institutions just indicate that it's a special online institutions that training and teaching undergraduate students. We have so many departments currently. This is just like a physical institutions, but it's not a physical institution, it's online institutions. Everything we are doing online. Every kind of the service that we are providing online in order to help even distant students and also to apply the knowledge of telecommunication engineering that we have been learning for 4 years, and we've been applying different aspects of life for more than 3 years right now. So the vision we have is actual. We have an assignment to teach and train, incubate, mentor, and lead some group of undergraduate students in Tanzania and other countries, just to learn, to teach them on how they can extract knowledge, wisdom, and understanding from the classroom instructions, whether formally or informally, and combine with the knowledge, wisdom, and understanding that we are going to extract to teach them how to extract it from the Word of God that written in the Holy Bible in order to solve real life problems. The main objective of Online Undergraduate Polytechnic Institute of Tanzania is to see our students whether they have graduated or they are still continuing studying undergraduate programs in different institutions or colleges or universities. They are solving real life problems. We don't mean that you are solving questions in the class. The questions in the class actually are imitations of what we have to find in the real life. So that is the main objective of these institutions, is to see our students when they are still studying and after they graduate, they are solving at least one particular real life problem. That is our main objective, and we like to induce in your mind, we like to write in your mind for the rest of your life. You have to know that there is a real life problems that are waiting. For example, myself here, I'm solving a real life problem. So simply, I'm a national engineering mathematics teacher who is teaching engineering mathematics to the different generations, present and future generations in Tanzania and even worldwide also, because the internet is not limited. So that is what should remain in your picture or in your mind. So before we start our session, whenever you join registration, you join any institution or any college or any university, the first thing that you are going to encounter during the first day when you arrive is what we call registration. So how are you going to be registered in registration authority of Online Undergraduate Polytechnic Institute of Tanzania? Okay, so simply it's registration just take less than a minute. It's not like registrations of physical institutions where you can spend a day. That's still going to the bank, doing this and doing that, and going to this table. So here, just within 1 minute, you do one registration, and there's no semester registration. Your registrations is once a time. So I insist you that you get registered in order for you to be active member of Online Undergraduate Polytechnic Institute of Tanzania. So the first step is you have Yahoo or Gmail email. So have an email, either Yahoo or Gmail. That's number one. Number two, we ask you to sign in YouTube platform. Okay, sign in YouTube platform by using your Yahoo or Gmail as the means of signing in. And then number three, means that search for Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAI. So search for this name. Just write this name: Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAI. So this is the abbreviation of each. Once you are there, you'll see a button that click this button. The button switch has been written. So click this button, which has been written as what? Okay. So it is, click the button which has been written subscribe. Once you click that button, it will change into subscribe, and also the bell is going to appear. Click it and then choose the options of all. Then you're done. You're done. This is the one-time registration. You don't need to subscribe several times. When you subscribe once, it's okay. Why should you subscribe? That's a very important question. Subscribe, it's an English term, which means that you are allowing to be given the information about release of a new product or a new brand. That's the meaning of it. So with content of YouTube and even some other software, for example, also site also has an option of subscribe. It means that you are giving YouTube community permission to give you notifications once OLENJOLAI uploads or adds a new video in Online Undergraduate Polytechnic Institute of Tanzania. We are teaching 12 modules or 12 courses in this in the departments of higher engineering and scientific mathematics. So we are planning, or we have a vision to have or to record more than 500 videos. So for you to get notifications from the YouTube once you are online, please make sure that you register yourself once, not a semester registration. Even when you graduate, also you'll get notifications of some other issues, because also after a short time we are going to have a graduate community, which we call them alumni of Online Undergraduate Polytechnic Institute of Tanzania. So I don't want to waste much of your time. I know that you want to get the good news that we've prepared before you. We need serious students. We are very serious in this program, and we are here to solve your problem. So whether you have been wandering around or you've been confused on how you can master or how you can understand the module or the course called the linear algebra, so you've been going around reading different books, surfing through the internet, I have a good news for you right now. And this is the good news, that we are here in order to help you to understand. We are here in order to help you to master. We are here in order to help you to see and enjoy the beauty of higher engineering and scientific mathematics, and also enjoy the beauty and understand and comprehend linear algebra. So we have so many departments. One of the departments is called the higher engineering and scientific mathematics. In these departments, we are teaching you or undergraduate students 12 modules with the focus of the curriculums of the higher education curriculum of United Republic of Tanzania in undergraduate level. So that's what we are teaching, and one of the modules of course is called linear algebra. So we have a quick review of lecture 2. So in lecture 2, we are in chapter 1, that's called matrices. In this lecture series, partitioning matrices and submatrices, And these contents are for the first and second class students, right? Great. So in lecture 2, we taught you about special matrix. Special matrix, special types of 40. Special types mean that we learned almost 10 types of 40 special types of matrix. We didn't finish yet, but that's what the syllabus asked us to teach you, introduce to you. So special types of 40 of matrix, that's the title of lecture 2. So in those special types matrix, we learned about column matrixing, we learned about row matrixing, we learned about identity matrixing, we learned about zero matrices, okay, zero matrices. Then we learned about square matrices or square matrix. Then we learned about some other concept. We learned about horizontal matrixing, vertical matrixing, scalar matrix, and I left the homework for you. So learned about scalar matrix. Scalar matrix. We learned about horizontal matrix, horizontal and vertical matrices. Okay, etc., 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 etc. So we have covered different types, and we gave you example of that particular matrix. So today we are still dealing with matrix, but today we want to take a new look on matrices. And this is the terminology called the partitioning matrix and the sub-matrices. So before we go further, we'd like to ask you the first question for this session, but because it's lecture 3, you can say question 3.1. And question 3.1, we have to ask ourselves, and even yourself, you have to ask what is partitioning? What is partitioning matrix? What is partitioning matrix? What the meaning of partitioning a matrix? Okay, I found a very interesting definition that I want to give you for you to understand, because you used to have partition in integrations, partitions in polynomial function. So that is especially that in type 1, type 2, type 3. So what is partitioning matrix? Simply, this is the one of the definition, say that the partitioning, say with me, partitioning. Partitioning of what? Of a matrix is the technique of dividing. The technique of dividing or partitioning a matrix. Partitioning a matrix into smaller matrices, into smaller sub-matrices, simply by adding in horizontal and the horizontal or vertical lines. horizontal or vertical lines. Okay, or vertical lines between selected row and the or between selected row and the columns. That's the meanings of partitioning of a matrix. This is the technique of dividing or partitioning of the matrix into smaller submatrices. If the word submatrix is confusing you, you can replace it with the word into smaller matrices. Simply by what? How do you split? By adding in horizontal or vertical lines between selected row or columns. Or partitioning or submatrices or smaller submatrices or smaller matrices can be formed by adding horizontal and the vertical lines between row and the columns. So this is the kind of the new matrix that we've never discussed about it, but the original matrix will have its own entities or elements. But in case of this partitioning matrix or submatrices, its elements or entities will be the combination, when it's the addition of some elements. So I mean, in submatrices we have smaller matrices, but which their elements are not determined the ordinary. That the means of partitioning of a matrix. Okay, ladies and gentlemen, are we together? If you have any question, please ask in the comment section. So remember that the reference syllabus that you are referring here is Udom, University of Dodoma. All right. So if that's the case, you have again the second question. We have seen another vocabulary which is called the submatrices. What is submatrices? What is submatrix? What is submatrix? That's the question. Simply say that submatrix are the smaller matrices formed by adding in horizontal and the or vertical lines horizontal or vertical so submatrices are the smaller matrices formed by adding in horizontal and the or vertical lines. vertical lines, between selected rows. Between selected rows and the or columns of Beng matrix. Main matrix. So according to this definition, say that these are some matrices which are smaller matrices compared to original one. They have been formed by adding in horizontal or in the vertical lines between selected rows and the columns of main matrix. Okay, so that the definitions of 14 of submatrix or submatrices. These are the definitions of matrices, but the person or the branch that we are discussing is not the person's actual. I mean that this is the small matrices. So this one we call it. So we say that the submatrices. Submatrix is also called the. So say that submatrix is also called a block. A block of what? A block of, or it's called also a block of matrix. So submatrix is also called a block of what? A block of matrix. And another name of what? Of submatrices. Okay, so I believe that you are still enjoying these contents for the rest of your life. Again, I want to remind you that you have also an online undergraduate library where we are equipping our students with very important materials for them to go further. And one of the items that we are distributing and we are sending into different 31 regions is the scientific calculator, example Cassion function 996. Okay, so that's what you have to make sure that, so you can order this scientific calculator. Okay, so let us continue. So remember that I have already defined the terminology called the partition. Partitioning of what is partitioning of a matrix? So this of a matrix. So we say that partitioning of a matrix is a technique of dividing or partitioning a matrix into smaller submatrices. Simply, how do we partition or how do we get those smaller submatrices? Simply by adding in horizontal and vertical lines between the selected row and the selected columns. Or partitioning of a matrix is a technique of dividing or partitioning a matrix into smaller submatrices simply by adding in horizontal or vertical lines between selected row or columns. That the definitions of what is partition. Remember that the title of the lecture 3 is Partitioning of a Matrix and Submatrices. So I'm building a strong foundation. I know that this is the new concept. We don't take our advanced students about partitioning a matrix. So this is the new concept. So I have to lay out the foundations of partitioning and matrixing in your mind, and you have to remember for the rest of your life, because you need it in solving real life problems, and especially real life engineering problems and real life scientific problems if you are doing the scientific programs. Then the second term, which this one is just it means question number 3.2. What is submatrix? We saw the word submatrix there. Here we saw the word submatrix, but in plural. Submatrices are the smaller matrices. So these are the smaller matrices formed by adding in horizontal and in vertical lines between selected rows or selected and selected columns. So between selected rows and selected columns. Okay, so these columns is plural of 40 of a main matrix or original matrix. In other reference books, submatrixing is also called the block of a matrix. Block of 40 of a matrix. Again, some of the references, for example, the Wikipedia gives another definition or alternative definitions of 40 of a block matrix. So submatrixing or a block matrix or a block 40 matrixing, block matrix is a matrix. Is a matrix that is so this is alternative interpreted as having been broken. Okay, that is interpreted as having been broken into blocks. Having been broken, so that matrix has been broken into blocks or submatrices. So the word sub always is something small. At the meaning of the word sub. So a block matrix or submatrix, in other words, is a matrix that is interpreted as having been broken into blocks. So it's a certain matrix which have been interpreted as it has been broken into blocks or submatrix or submatrices. That's alternative definitions of block of matrix. So, my dear student who is learning linear algebra, especially you who is doing your undergraduate studies at the University of Dodoma, because this is the course given as TN 111 at University of Dodoma, and we are using your curriculum wonderfully enough. So you should be the first person to benefit on these programs of linear algebra. So, or submatrix. Submatrix. Okay? So this is an alternative definition of submatrix. So, ladies and gentlemen, after giving you the descriptions of the meanings of submatrix and the meanings of partitioning of a matrix, then I would like the reference explain what the meanings of a matrix interpreted as a block matrix. Okay, so then the literature say that, especially the Wikipedia, a matrix interpreted as a block matrix can be visualized visualized as the original matrix, with a collection of original matrix is a collection of horizontal and vertical lines. As a collection of horizontal and vertical lines, which breaks it up. Tell your neighbor Olenjolai is building a strong foundations of submatrix and the submatrix and partition of the matrix in my mind. Tell your neighbor like that. Okay, which breaks it up into a collection of small matrices. So ladies and gentlemen, we say that a matrix interpreted as a block matrix can be visualized as an original matrix with a collection of horizontal and vertical lines, which breaks it up into a collection of small matrices. So what are we trying to build in our mind? The key point should be in your mind. We have a main matrix which contains its entities or elements, maybe a 2x2 matrix or 5x3 matrix or 5x5 matrix or 4x3 matrix of the kind of the different size. And then we can formulate a new matrix, but by either adding horizontal lines and vertical lines. So the element of the new matrix, which is called the smaller matrix or submatrix, will be the combinations of the elements, means that one will be the combinations of the different elements of the main matrix. So that's what we call the submatrix. So submatrix is a subset of the main matrix, but its elements are not the one which have been given, but its elements has undergo what we call the basic operations. Okay, so basic operations, which is an addition. So it has undergone like that. It's a combination of more than two elements of the main matrix. So each element of the submatrix is a combination of more than two elements of the first matrix, because we taught you about the special types of the matrix. We taught you about column matrixing. We taught you about row matrix. We taught about square matrixing. So we can construct a submatrix by just partitioning the main matrix into different types of the special matrix, which we have already taught you in lecture 2. All right, that's the point you have to remember in your mind. So ladies and gentlemen, right now, let me just explain to you about just it means a question. Okay, so we say that the partitioning of a matrix. So let us begin. Means that practical, we say that because I want to deal with the general concept. So we say that the general partition. So we say that in partitioning a matrix. So partitioning a matrix in general. So partitioning a matrix in general. Partitioning a matrix. So you say that in algebra or in linear algebra that we are teaching you, there are several ways of partitioning a matrix into submatrices or into blocks. So you have to understand there are several ways, not only one way. There are several ways and several alternatives, but that does not limit mathematicians to learn about the subject, to learn about some few partitioning of the matrix. Okay? So let me just teach you how we can find at least 3 ways of partitioning a general matrix, which will be given, and then I will give you a numerical example. Then so we say that so we say that because there are the several ways of partitioning in matrix, so we say that in this module or in this course we can study some of the few ways of partitioning a matrix into submatrices, into submatrices. Okay? So this is example. So you can call it example 1. But we'll discuss in general perspective, a general example. Okay? So you say that given a 5 by 3 matrix A below, then show 3 ways of partitioning a matrix A. There are several ways, but just to show at least 3 ways of partitioning the matrix A. So matrix A has how many elements? So it has 5 rows, so which you define as A1, the first row, second row it is A12, third row it is A13, fourth row it is A14, and then fifth row it is what? It is A15. So then the next column is A12 and the A13. So this is so this is 2. Choose me about this labeling. It's not correct. Okay. So I made a mistake in the first column formulating the rows. So let me do the minor correction. So the element of the first column is A subscript of 2, 1, A subscript of 3, 1, A subscript of 4, 1, A subscript of 5, 1. Then we have this one. So this is A subscript of 1, 2, A subscript of 2, 2, A subscript of 40, 3, 2, then A subscript of 4, 2, then B, then A subscript of 5, 2. Then we formulate the steady column. So the steady column is A 230. Then we have A, subscript of 3, 3. Then we have A, subscript of 3, 4. And we have A, subscript of 3, 4. Excuse me. This is subscript of 4, 4, 4, 3. And we have A, subscript of 5, 3. So this is our body. So the size, don't confuse size and location. Size of this matrix is just 5 rows. 1, 2, so 1, 2, 3, 4, 5. It has how many columns? It has 3 columns. First column, second column, third column. So it is A11 to A21 to A51, then A12 to A52, A13 to A53. Wonderful. So that's the given matrix. So original matrix, which has how many elements in total? So it is 5 times 3. It has how many elements? 15 elements. So we have a matrix A which contains 15 elements. So we have to think about different possible ways of partitioning matrix A. So, solution is the general concept. Solution. We are going to follow steps. The first step, okay, we say that the first thing, it doesn't mean that you should start with this. You can start with either the first possible way of partitioning what? The matrix A is this. So we can have our matrix A. So now we are focusing, we can list or we can copy it, and then we have to focus on what? We have to focus on partition. So here, ladies and gentlemen, we have A1, A11, then we have A12, then we have A13. Then the next row, it is A21, then A22, then A23. Then the next row, it is A31, A32, A33. Then the next row, it is A41, A42, A43. Then we have A51, A52, A53. So this is our matrix A. So this matrix A, we can do the partitioning in this style. So we can formulate the partitioning in this style. So the first possible way is we have 5 elements. We can divide this matrix in here to form a certain matrix, and again submatrix is another submatrix. So it means we form a matrix with 2 rows and a matrix with 3 rows. But we also remember the principle states that we may also divide a matrix by dividing only the rows, or by partitioning only the rows, or by partitioning only the columns, or by partitioning both. So let us start with the possible way of partitioning both. So if you start with the first way of partitioning the rows, so you partition the rows. These are the 2 rows, first row, second row, and then first this is first row for the second submatrix, second and third rows. So we have alternatives. We can divide this in column matrix here in this style, or we can divide at this point. So this is another submatrix, so it is another format of blocks. We can also have alternate. We can divide the column matrix in this way and have a matrix with a matrix with 3 rows, but with different values of elements, and the matrix with 4 rows. We can even also divide this matrix by using what? By dividing what? Its rows at this point. So we can divide like this, then divide like this one. So we have so many ways. So you see, so for example, in terms of rows, we can divide this one. This is a row matrix, a row matrix, a row matrix, a row matrix, a row submatrix. So you see different alternatives. Also, you can divide this one and formulate a column matrix, and this one formulate a column matrix, and this one formulate a column matrix. Remember that the matrix should have at least 2 elements, whether in column or in row. So let us memorize that this is our first partitioning of the matrix. And also let us divide the matrix at this, between these 2 columns. So right now we have what? We have seriality, we have 4 submatrix, right? So we say that we have what? So the second step there, we can extract this one. So it means that we say that listing, you can list what? Listing possible blocks. Okay, possible elements of 40. Okay, we say that in possible elements, new elements of 40 of block, of the first block, because let us form the first block. So we can name like this one, that suppose the first element of the block, we label it as A11. It's this first 40. So this is column matrix, which has 2 elements, A11 and A21. Okay, so if you define size, the size of this matrix is what? So 2 by 1, it's 2 by 1 matrix. Okay, so that the first element of 40 of our block or of our submatrix that we formulate in that first possible way of partitioning what? A matrix element. Remember that you have to concentrate. In case you have any question, don't hesitate to ask in the comment section, please. So the second possible element of the block, okay, second possible element of the block, we can label it A12. So we can combine these 4 elements of that submatrix. So it has what? 4 elements that we have to combine them by adding and then formulating A1. So A12, then A13, then we have A22, A23. So these are the elements of that will be forming the second element of what? Of the submatrix. Okay? So this is the second step. This is the third step, ladies and gentlemen. Then the fourth step, we can isolate what? So we can isolate what? We can isolate what? Elements of 40. Elements of second entity, third entity. Okay? Third entity of 40 of block matrix. So this we can formulate by using what? So it is A, so we can call it A21. This we can formulate by another column matrix of 3 elements. Okay? 3 elements, which is labeled as what? A31, subscript of 31, A32, or A41, excuse me. Here we have A4, subscript of 41, then you have A51. So these are the elements. So in terms of the size, so here, if you define the size of this matrix, is equal to what? This the square matrix, this 2 by 2 matrix. Okay? Also, if you define the size of this matrix, this is the column matrix, because there's 3 rows and 1 column. Wonderful. I believe you're enjoying the beauty of 40. I believe you're enjoying the beauty of matrices in linear algebra. Wonderful. Okay, and this is it's a new concept. So the fifth step now, we say that we can isolate what? Isolate the first element of what? Of a block. Okay, how? So we can call it A22. This is a 3x2 matrix. So it's what? A32, A42, A52. Then another column is A33, then A43, and then this is A53. So this is what? Size is equal to what? It is 3 rows, 1, 2, 3, by 2 columns, 1, 2. Okay, that is the first entity of the block matrix. Okay, so ladies and gentlemen, we go now into the fifth step, the sixth step. Okay, the sixth step. We say that now. We say that write the block matrix or the submatrix, block matrix or submatrix of 40 of A. So we say that the first submatrix of A will be is given as what? This is given as A is equal to, so we can use ASAS. So we have how many elements? 4 elements. So it is 2 by 2 matrix. The first element is A1, 1. So this is the combinations of how many? 2 elements of the original matrix A. And this is A1, 2. The combinations of elements, 4 elements of original matrix. Then you have A1, A2, 1. The combinations of 3 elements of the original matrix. Then you have what? A2, 2. This A2, 2 is the combinations of 40 of 6 elements of the previous 40 matrix. So then, ladies and gentlemen, the size is equal to what? So the size, it is 2 by 2 matrix. So this is 2 by 2 matrix. It's a square matrix if we name according to what I taught you in lecture 2. Wonderful. So that is the first possible way of formulating what is a block matrix. So according to the question, we've been asked how many possible ways? 3 possible ways. So you can pause the video right now if you've understood and practice yourself partitioning a matrix or a matrix A with the size of 5 by 3 and finding the second block. And then you check the corrections. You click the buttons of play, you check the corrections. If you got it, congratulations. If you missed it, don't worry to learn from mistakes. Okay, so then we go, ladies and gentlemen, with the seventh step. So the seventh step, we say that the second possible way of what? Of partitioning a matrix A is this. So you can have our matrix A, okay, so you can have our matrix A. So we can simplify it this way. So we can have our matrix A, which has all of these elements, and then we partition it in a different way. Remember, we say we have so many possible. You can even partitioning this matrix by using other partitions that I'm not discussing, or I didn't discuss in this aspect or in this general concept. So we can partition. So in the first possible way, we partition the columns and columns and rows of the matrix A. So the second one, we can only partition the rows, the columns, right? So this is the first column. We partition a matrix A at this point. So we have formulated three new entities if we combine these elements, right? So the second step, we say that list so this will be not the second step now, it will be the eighth step. We have to list the possible elements of even there a mistake of first entity or element of a block. Okay, of a block. So if you want to list it, then we are going to list it as a new as a new. So because this is columns, we may use instead of using notations of A1, A2, we can use now the symbol because we are going to formulate submatrices, which we call them, it's a submatrix which has been formed by columns of a given matrix. So it means that the first, so remember that this one will be the first entity of the submatrix, the second entity of the submatrix, the third entity of the submatrix. Means the combinations of these 5 elements formulate the first elements of the matrix, the second elements of the submatrix, and the the third elements of the submatrix. So it means that we can just analyze in this way. So it means that we can call it C1, okay? Because we have only row, we have only column, okay? This is representing column, the first column. It means the combinations of the elements of the first column will be A11, A21, A31, A41, A51. Okay, A51. So if you define the size of this matrix, we say that this is 5 by 1 matrix. Okay, then we can formulate it. So we can go the 9th step. Don't worry about the number of steps. The issue is understand. The 9th step, we say that let us list the elements of possible elements of second entity of a block of block 2, that's of the second block. Okay, so this we call it will be the second column, right? Also it will be formed by the elements that we have in the second column. Okay, so these elements have been labeled A21, A21, A12, 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 then A22, then A32, then A42, then A52. So simply, this size is equal to what? 5 rows by 1. At the size of the matrix C2. Okay. Again, let me list the elements that will be forming the same entity. So this one will be the 10th step. 10th step, list elements. List elements of 40. List possible elements of 30 entity of second block according to our choice. So this we can label it as 3. Okay? So we label it 3. This is A, 1, 3, A, 2, 3. Did A, 2, 3? Yeah. So then again A, 3, 3. Then A, 4, 3. Then we have what? A, 5, 3. So this is a list of 40 of elements. So if you want to define size, how many rows do you have? 5 rows. How many columns do you have? Only 1 column. So we can add this, maybe we can add the lines, the horizontal, the vertical lines, and then get C1, C2. So ladies and gentlemen, the 11th step right now, the 11th step is we can write the second block or submatrix, block matrix. So our second block matrix now, we say that suppose that the original matrix A now, we can formulate a row, a column. Will it be a column? Yeah, column matrix. Column matrix. So because the column matrix can formulate C1, C2. No. We have columns, so we can write. So this is the first column, second column, third column. So because you have the combinations of columns, we formulate a row matrix. So our row matrix for this case will have what? Will have the following elements. Okay? So the first element is C1, the second element is C2, the third element is C3, which is the combinations of 5 elements of original matrix, combinations of 5 elements of original matrix, combinations of 5 elements of original matrix. So the size of this second block, okay, the size of this second block is what? How many rows do you have? Only 1 row. How many columns do you have? It is 1 by 3. So that the possibility is the possible second right? The possible second block matrix. Wonderful. Do you understand what am I teaching you? Real for me, I enjoy what I'm teaching you because I love so much higher engineering mathematics. I love so much higher scientific mathematics. But remember that Olenjolai does not know everything about higher engineering mathematics. I know just a small portion, but I'm ready to teach others what I know, according to an assignment that God has given me when He built His own chiefly for His own glory in me of the teaching, just like how He has built a chiefly of swimming in the fishes. So when fishes, they never get tired to swim. It's just like me, I'll never get tired to teach. And fishes, they will never attend any swimming school, right? Any swimming school. It's just like to me, whether I attend a training on teaching or not. Teaching is built in me. I am a teaching, and teaching is me. According to God's word, He used to tell me that my son Olenjolai, my child Olenjolai, you are the gift of Tanzania, especially in the area of education and engineering. So it's a matter of you to receive what I have or to reject it. But my advice, receive what I have for the benefits of your life and for the benefits of the humanity. Okay. So let me take you into the last step now, the third possible way. So that will establish the 12 steps. Okay? 12 steps. So in these 12 steps, we say that the 30 possible way of forming the 30 submatrix. I use the word block and submatrix interchangeably. Submatrix A is this. So we have to list all the elements of matrix A, which is 5 by 5. And right now, we say that this is A11, A12, A13. Then we have A21, A22. If you do this, problems you get experienced on writing these elements of the matrix because they follow a particular algorithm. So A32, A33. Okay? So A41, A42, A43. Then you have what? A51, A52, A53. So ladies and gentlemen, this is 3 by 5 by 3 matrix. So we in the second possible way, we just did partitioning on what? Basing on what? Partitioning based on partitioning what? The columns of the original matrix. Right now, we want to partition the same matrix, but with a good focus on partitioning what? The rows. Okay, we can partition, we have possible ways of partitioning rows itself. Okay, so remember that this one is, we call it column. It has a special name. So let me just give you its name. We call it column matrices. Column matrices of A. So the CI is partitioning matrix, are sometimes called the column matrices. So this one, we can call it AA, or in general, we can just call it CI. So we say that CI is also called what? Column. Why? Because it's being formed by partitioning columns. So column sub matrices of what? Of A. Column submatrices of A. So this is called what? Column submatrices of what? Of A. So we have different ways also of partitioning this matrix based on the row. We can only just put a line partitioning here and form it what? A matrix, a row matrix, a column, okay, a column matrix of 2 elements. That will be formed by a combination of these elements and combinations of the 9 or 40 of the 12 elements, right? You can also partition in this system. There are so many ways of partitioning basing on what? Partitioning rows of 40 of the matrix. So each of them, if I just put this first line, that's the first possible way, even this one, the second possible way, third possible way, and also so this is just, let us encounter as a first, the one possible way of partitioning the matrix A. So in this context, it's just like how we have partitioning the entire matrix by partitioning each column. So even here we have partitioned each row. Remember that I told you that you can partition matrix A by using any other ways that I have not mentioned. So it's your homework right now to think about other possible ways of partitioning matrix A without copying mine, which I didn't mention or I didn't discuss in this session. But remember, when we give you questions, at least we limit you. We give you some information in order just to simplify the concept. So the 13th step, ladies and gentlemen. So you have how many entities? So the first entity will be formed by this, the second entity, third entity, fourth entity, fifth entity. Okay, so we know right now that and these entities are rows. So it means that we say that listing, so in general we say that list 30 entities of 40 of 30 block matrices. Okay, block 40, 30 block matrix. So block matrix of block matrix as what? As row. So it means that simply we say R1 it will be what? It will be a matrix which is formed by A11, A12, A13. So this is what? This is it's 1 times what? 3. So it's 1 by 3 matrix. So this is the size. Remember that this is what? This is the size. The second entity will be formed by adding the elements of the second row. So that new entity will be R2. So R2, we have what? A21, A22, A23. If we want to define the size of this matrix, it's what? 1 by 3 matrix. Okay? Then we have the third entity, which is R3. Its elements are A31, A32, A33. Then the size is equal to 1 by 3. Then we have the fourth entity, which is R4, to be formed by what? A41, A42, A43. So the size is equal to what? Is equal to 1 by 3. Then we have the fifth entity. The fifth entity we have what? A51, A52, A53. So the size is equal to 1 by 3. Right now, we can formulate a new matrix. So we say let the third submatrix to be equal to what? To be equal to Ri. Use raw submatrices of A. So raw submatrices of A, this is the steady block, to be formed by what? By raw matrices. Okay? No, it will form a column matrix, not a row matrix. So this one is going to form what? A column matrix. Column matrix will be formed by rows of the original matrix. So we say that Ri, this will be formed by what? The R1, which is the first row, R2, which is the second row, R3, which is the third row, R4, which is the first row, R5, which is the fifth row. So the size of this matrix, how many rows? Is 5 by 1. So because it's just like that, so we say that, therefore, so we say that, also we say Ri is called this is what? Raw submatrices of A. So keep these words because we are going to use them for 40 of A. So raw submatrices of 40 of A. And then at the end of the solution of the previous problems, which was the general matrices. Okay? That was example 1. Ladies and gentlemen, let me introduce to you example 2 of partitioning matrix. Okay, wonderful enough. God loves you so much. Give God thanks. So I can give you the example what. So before example 2, we say that, as we say, there are so many different ways of partitioning a matrix. So we used to say that there are of course many other ways to partitioning this matrix. We won't be partitioning up too many matrices in this course, but we'll be doing it in occasion. So it's a useful idea to remember. So you have to remember this concept because we are going to record it. Okay? So we say that, so not before, there are other different ways of what? Of partitioning a matrix, partitioning matrix A. Okay, but we want partitioning too much. Partitioning too much in this course. In this course. So now let me give you example 2. After example 2, I will give you the homework. Right? So I'm about to end this interesting session, interesting lecture. Isn't it? Tell me in the comment section, please, you're enjoying this content from which country. Remember also to register yourself by subscribing into our channel, and remember to invite your colleagues to enjoy the beauty of linear algebra and higher engineering mathematics that focuses in this is the special training and teaching that we are focusing on the syllabus and curriculums of United Republic of Tanzania. Okay, in all the engineering institutions, colleges and universities, these are what we used to cover. So I'm unlocking it in order to benefit present and future generations. So we may go far from the point we used to end, because we are not learning these contents in order to pass exams only, but we have to learn in order to think differently on how we can solve our real life problems. We have so many real life problems, and the good news that God has a plan and has a vision just to make our beautiful country Tanzania, and this is our national flag, okay, to be the industrial country. So in order for us to be industrial countries, we as the people who knows the voice of God, we have to prepare engineers who will work excellently in those industries that God is going to give us an idea to establish. So those industries and that industrial economical will be successful. So that is one of the objectives of this training that we are providing in online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Tell yourself, I am an engineer called by God, if you believe that. Okay, so example 2. So some of the examples can be given to narrow your concept. We say that given a matrix Q, so in the previous example we used the letters below, and this matrix Q. So in this one now, we are going to use numbers. Okay, so you have 1, 2. We don't discuss in partitioning of the matrix on how we add those elements of original matrix in order to form what? In order to form blocks of that matrix. Okay, we just show you how we can partition a matrix. That's all. Okay, because I know that your questions is how we can add them. Okay, we are not discussing about operations of matrix. That's the next subtopic. Okay, the next subtopic I will teach you about matrixing operators, or operations on layout or matrixing. And we just repeat what we taught you in advanced education level or in ordinary diploma level, and then we add new concept in your mind, because that's the objective of higher engineering mathematics and higher scientific mathematics. That's the one of the objective. So possibly we have 2 lectures of 40, which will focusing 2 to 3 lectures, which will be focusing on matrix or on operations of the matrix. So then the question asks you that. So in linear algebra, there are different ways. There are different ways of partitioning a matrix Q. Okay, partitioning a matrix Q. So there are several ways. So we limit you, right? So partition a matrix Q. Partition a matrix Q. Matrix Q into a block of entities of what? Of 2 by 2 subworting 2 by 2 of 2 by 2 submatrices. Okay, 2 by 2 what? Yes, submatrices of 40 of matrix Q. The question. So you have to partition. So given a matrix Q below, this is what? So in terms of size, it is what? 4 by 4. Is it 4 by 4? Yeah, 4 by 4. 4 by 4 matrix. So it's a square matrix. Then we agree that in linear algebra, there are different ways of partitioning a matrix Q. It is true. But not in this question, we ask you to partition a matrix Q into a block of entities of 2 by 2 submatrices of matrix Q. Solution. What matters? No, first the size. The first state size of Q is what? 4 by 4. That's a very important piece of information. Then the second state right now. So we say that partition a matrix Q based on what? On given condition. Based on given condition. Remember, we have several ways. We have different ways, several ways of partitioning a matrix Q. Ladies and gentlemen. But we've been limited that should form a block, one block matrix, not more than one. We've asked it to form one block matrix, but with 30 entities, with a 2 by 2 entities. So to partition this matrix Q, can just have this matrix Q and list the elements first, which is 1, 2, 2. Okay, so 1, 2, 2, 7. 2, 2, 7, and then we have 1, 5, 6, 2. Then we have 3, 3. Then we have 4, 5. Then we have 3, 3, 6, 7. Okay, 7. So we can partition this matrix by partitioning the column. We just partition the column only once, and we can partition also the row only once. Then the next step is we have to list the entities of the block matrix. So we partition, so we have one entity, second entity, third entity, fourth entity. So we go for the third step, 1. So I believe that now you've understood what I've been teaching you. So we say that list the elements. So we say that isolate what you say, isolate the first entity. So to isolate the first entity, this we can call it Q11. So the Q11 will be formed by 2 by 2 matrix with elements of 1, 2, 1, 5. And the size of this matrix is 2 by 2, so the square matrix, so it has met the condition. Then Q by what? So the first step, so isolate the first step. The first step now, because we know the algorithm, we say that isolate what? Isolate the second, the third, and fourth. Okay, and fourth what? Entities of the block what? The block matrix. Okay, so this is what? Q12, and this is equal to what? This is equal to 2, 7, 6, 2. And then Q what? 2, 1. This is a 2 by 2 matrix. Remember that the size of this matrix 2 by 2 matrix. So there we have what? Have again 3, 3, 3, 3. Okay? The size of this matrix is what? 2 by 2. Okay, then finally we have the first entity, which is Q22. So the Q22, for this case, it is 4, 5, then 6, 7. So its size, this is equal to 2 by 2. Then we go for the 50th step. The 50th step, we say that now let us write what is our 2 by 2 block matrix. Block matrix. So how do we name this? So we can name that our new block matrix, which you can call it I. Okay, I, if we are using maybe these letters, I. So it is simply what? It is Q11, Q2, Q12. It means like this is the square matrix. Okay, not identity, it is a square matrix. So you can say maybe SI, it's a square matrix. And this is Q12, then you have Q22. So this is the square root. So we can find that SI is called what? It's called what? It's called a square sub matrix. Submatrices. Submatrices of what? Of A. Okay? So at the response. So it means that therefore the two, according to the question we've been asked, that the 2 by 2 submatrices. So we take the block of 2 by 2 submatrices of A is given as SI is equal to what? Additions of elements that forming submatrix Q1 and elements that forming submatrix 1, 2, and elements that forming submatrix what? 2, 1, and elements that forming submatrix 2, 2. So this is the final response. Ladies and gentlemen, I know that now you are well satisfied. You are more than satisfied about partitioning of a matrix and submatrix. I believe that you have got the general concept, the detailed. So now it's a time for me to test you, whether you understand what I've taught you or not. Homework, which is this called HW, this is homework 3. So this is example 3. Example 3. Okay? Example 3. So example 3 states that refer example 2 above. Okay? Partitioning So refer example 2, example 2 above. So that I've told you, we say that partition a matrix Q of these elements, of these elements. It's one of the simple, or one of the simplest homework. So the elements are 4 by 4 also, -1, 0, 1, 2, then -5, 9, 3, 5, then we have 8, 2, -4, then 3. We have -7, 1, -6, 7. So just means that form what a 2 by a block, just one block of 2 by 2 matrix by 2 by 2 entities. So, ladies and gentlemen, who are doing undergraduate engineering or undergraduate science courses in Tanzania and internationally, this is end of lecture series. I'm happy because I've poured the portions of what I know about matrices in higher education. But really, I'm still eager and I'm waiting you, and I would like to invite you in lecture 4, when I'm going to teach you about operations of the matrix. It will be the last concept for this first chapter of the matrix, of the matrices. I know you know, but we'll take you always, we used to add a value on higher engineering mathematics from what you knew in your ordinary education, ordinary diploma education, and also on what you know if you pursue advanced education. So we always remind you what we taught you, and we add a value. So we add a new concept in your mind. I believe that you'll be well prepared, you'll be serious, you'll be more focused, you'll invite so many of your classmates, of your college mates, institution mates, university mates, and remember that there's no limitations of these contents. You can access these contents at any time, and you can access these contents anywhere. So it's a time for the digital education in higher educations in Tanzania in order to educate the digital age, because we need this technology and we need this knowledge in order to solve our real life problems. In case you have any questions, don't hesitate to ask in the comment section. Again, we have online undergraduate library where we have different reference books in higher engineering mathematics and higher scientific mathematics, soft copy and hard copy, and also we have a scientific calculator, which I can show you one of the sample that I use. I use this scientific calculator for 3 years. Okay, for 3 years, without it has been falling down. Then I picked it up, and everything is still working as how it has been designed by the manufacturer. We are selling to you, or we are providing you original scientific calculator so you may use during your entire learning of 4 engineering course or 3 years engineering course. So don't wait. Go to the descriptions, click the software buttons that called show more, then it will take you into more descriptions, and check the link that will show you the price of the different items and the shipping cost in all 31 regions of Tanzania. Again, mostly I know that you have been shocked about what God has given you in this platform. These contents actually are very expensive if you want to pay for, but God is faithful, He has paid for you because He's a sponsor of my God is a sponsor of Online Undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM. So, but God invites you to offer your free willing Thanksgiving offering of any amount in order for you to support the running cost, so that more than 500 lecture videos of higher engineering mathematics and higher scientific mathematics will be in air through the power of the internet. It will be accessed by the present generation who will be one who want to be excellent engineers and excellent scientists in our country. And also it will be accessed by the future generation. So you are planting a seed into your beautiful country. You are not providing the free will thanksgiving for my own expenditure. You are providing in order to pay for the high running cost for this platform or for this program to benefit humanity and to benefit Tanzanians and also non-Tanzanians, because the internet is crossing the borders. So may God bless you. I thank God who have created me in his own image and likeness. And I thank God who have given you a chance to join me in lecture series. I believe that may God will give you and remind you against to get registered. So when we add lecture 4 of matrices, when I'll teach you for the, I'll build the foundations of the operations of the matrix, you'll join me. But also you'll join me in some other courses of other institutions or universities in case that your contents are not, or this your contents or your curriculum does not demand on this. We are teaching different topics of matrices, of linear algebra, so you have to check into the channel because that is what we used to do. So may God bless you and keep you. Keep on praying for me. I always pray for all my online students. Keep on praying for me and I keep on praying for you. Then enjoy the beauty of higher engineering and scientific mathematics. And I want just to tell you this. You heard this phrase. I heard this phrase when I was in standard 1 of my primary education. People used to believe and people used to proclaim that mathematics is a national disease. In Swahili, we just say that hesabu is ugonjwa wa taifa. I disagree that phrase, that sentence is not true. Mathematics is not a national disease, but mathematics is the best solutions of solving national real-life problems. So if you've never used mathematics in your life, just stay connected with online undergraduate Polytechnic Institute of Tanzania, then we'll change your way of thinking and we'll see how you use mathematics in music, in your daily life, in engineering, in different aspects of life. So may God bless you. This is Sir and Engineer OLENJOLAI Moko TAYAI Losingo, simply just Sir and Engineer OLENJOLAI, who is real declaring the truth and the beauty of higher engineering and scientific mathematics. See you in lecture 4. I'm really waiting you. Don't miss it.